Let me ruin a diagram you have trusted since you were 6. The one where the arteries are red and the veins are calm, refreshing blue. Here is the problem. The blood in your veins has never been blue. Not once, not for a single heartbeat in your entire life. You have been lied to by a textbook with a coloring budget. Your blood is red right now. All of it. The bright stuff leaving your heart, the tired stuff crawling back. Cut yourself anywhere from any vessel, and what runs out is red. The only place your blood looks blue is in a picture where an artist needed you to tell 2 pipes apart. Your body never got the memo. And you can prove it on yourself in about 4 seconds. Look at the back of your wrist. See those calm blue-green rivers? That is your circulatory system, allegedly running with blue blood. Now go get a paper cut over one of them. I will wait. It comes out red, doesn't it? The vein did not change its mind on the way out. So why red? It comes down to one ridiculous detail. Floating in your red blood cells is a protein called hemoglobin, and buried in the middle of it is iron. The same iron as a nail, a railing, an old car door. Your blood is red for the exact same reason rust is red. You are running on slightly fancier rust. That iron has one job, and it is a clingy one. It grabs oxygen. Every breath you take, oxygen rushes into your lungs, and that little iron atom snatches it and holds on for dear life. That grip is the entire point of you having blood at all. No iron, no oxygen delivery, no you. It is a courier service run by metal. And here is the part that explains the whole color trick. When that iron is holding oxygen, the hemoglobin changes shape slightly, and that new shape reflects light as a bright, smug fire engine red. Oxygen-rich blood, fresh off the lungs, is the reddest red your body produces. That is the blood your heart is proudly pumping out to everything that needs it. Then your tissues do what tissues do. They strip the oxygen off, they take it, and the iron, now empty-handed, shifts shape again, and the blood goes a deeper, darker, moodier red, like wine instead of cherry. That is deoxygenated blood. Still red, just dark red. At no point in that entire round trip does it pass through blue. So if the blood is dark red, why does the vein look blue? Because the skin is the liar, not the blood. Light has to punch through layers of you to reach that vein and bounce back. Red light gets absorbed and lost in the tissue. Blue light scatters back out more easily. Your eye catches the leftover blue, and your brain calls the vein blue. Read that again, because it is genuinely sneaky. The vein is not blue, the blood is not blue. You are simply seeing the one color of light that survived the trip back out through your skin. It is a trick of leftover light. The textbook took that optical illusion, looked you dead in the eye, and printed it as a fact. Now, before someone gets clever in the comments, truly blue blood does exist in nature. Horseshoe crabs, some octopuses, spiders, but they cheated. They build their oxygen carrier around copper instead of iron, and copper goes blue when it grabs oxygen. So yes, blue blood is real. It is just that you, specifically, are not a horseshoe crab. You are running iron. You get red. Okay, so your blood is red. Where does the bruise come in? A bruise is what happens when you do something graceful, like walking directly into the corner of your own coffee table. The impact ruptures tiny vessels under the skin, and blood leaks out into the tissue. A small, contained, internal spill, and nobody is coming to mop it. You have to clean it up yourself. At first, that spilled blood is fresh and still carrying oxygen, so the bruise shows up red. Day 1, day 2, a reddish mark. This is the part you actually saw happen. But the blood is now stranded outside its vessel, in the wrong place, with nowhere to flow. And the moment it is trapped there, the cleanup timer starts. The colors that follow are a progress bar. Within a day or two, that trapped blood loses its oxygen, just like deoxygenated blood always does. So the bruise deepens into dark blue, purple, sometimes near black. Same exact trick as your veins. It is dark red blood sitting under your skin, and the skin scatters it into that ugly blue-black. People call this stage the bruise getting worse. It is just getting older. Then the real work begins. Your body sends in the cleanup crew, white blood cells called macrophages. The name literally means big eaters, and that is exactly what they do. They show up to the spill and start swallowing the wrecked red blood cells whole, hauling away the debris. Every color change from here on out is them digesting your spilled blood one molecule at a time. And they are not just throwing it in the trash. That blood is full of expensive parts, especially that iron. Your body refuses to waste it. So the macrophages take the hemoglobin apart, carefully pull the iron out to be recycled and reused, and start breaking down what is left. This is not decay. This is a salvage operation. Your bruise is being mined for scrap. When they crack the heme apart, they produce a new pigment called biliverdin. And biliverdin is green. This is the famous moment, around day 5 to 7, when your bruise turns a sickly green and everyone assumes something has gone horribly wrong. Nothing has gone wrong. Green is the receipt. Green means the demolition is working and your blood is being processed on schedule. Then biliverdin gets converted one step further into a pigment called bilirubin, and bilirubin is yellow. So the green fades into that pale, jaundiced, slightly gross, yellow-brown around day 7 to 14. Same chemical you make when your liver processes old blood every single day. Your bruise is just doing it out in the open, under your skin, where you can watch the whole thing. So look at what you actually have here. Red, then blue-black, then green, then yellow. That is not random. That is a fixed, repeatable chemical sequence, and it runs in the same order every single time, in everybody. Which means a bruise is not a random ugly mark. It is a readable timeline. The color is literally telling you how far along the recycling has gotten. This is so reliable that forensic experts use it. They look at a bruise on a body, read the color, and estimate roughly how old the injury is. Reddish blue, recent. Green, several days in. Yellow-brown, over a week. They are reading the bruise like a clock that someone painted onto your skin. The breakdown of your own blood, keeping time on your behalf, whether you asked it to or not. And then, of course, it disappears because the macrophages finish eating. The biliverdin and bilirubin get carried off and flushed out through your normal waste systems, the same ones your liver uses. The iron is already back in circulation, reincarnated into a fresh red blood cell. The spill is fully cleaned, the color drains away, and the skin acts like nothing ever happened. And the genuinely unfair part is, you contributed nothing. You did not decide to dispatch macrophages. You did not order the iron to be recycled. You did not schedule the green to yellow handoff. You walked into the coffee table, said a word you would not say in church, and your body quietly ran a flawless, multi-day cleanup with 0 new instructions from management. So let us put the two halves together, because they are the same story. Your blood is red because of iron grabbing oxygen, bright red coming, dark red going, and never, ever blue, no matter what the diagram claimed. And a bruise is that same red blood, spilled, then disassembled and recycled in a strict color-coded order. Red is the chemistry. The colors are the receipt. So, the next time a bruise blooms green and your stomach drops, relax. Green is not infection. Green is not rot. Green is your salvage crew partway through the job, holding up a pigment that means we are recovering the materials. The yellow that follows is them nearly done. You are not watching damage spread. You are watching a refund being processed, in color, in real time. You have spent your whole life thinking your blood turns blue, and your bruises just go bad. Neither was ever true. The blue was light playing tricks through your skin. And the bruise was never going bad. It was going green on purpose, then yellow on schedule, while your body quietly recycled its own spilled blood and put the iron back to work. Same red running through all of it. Even your worst-looking bruise is just your blood bleeding in the right direction, on time.